Greetings to all the viewers. This is a video presentation of our project on Intruder Alarm System, which is a part of our DA3 for the course Microprocessors and Microcontrollers. This project is done by S. Navneeta Krishnan, Sankarshan Mishra, and Shreyas Paricha. Talking about the presentation overview, this presentation consists of objective and introduction of our project, architecture and code implementation, result and references. Objective. The objective of our project is to design and implement a security system that detects unauthorized access to a protected area and alerts the appropriate parties of the intrusion. The ultimate goal of our project is to provide an efficient and cost-effective means of system which helps in protecting the area against theft and unauthorized access. Introduction. In general terms, we can define intruder alarm system as an electronic security system that detects unauthorized entry into a building or an area and raises an alarm to notify the appropriate authorities or people. Architecture of our project. For developing our project, we have used 8051 microcontroller, stepper motor, LCD screen, which is an integral part of 8051 microcontroller, keypad, PIR sensor, buzzer. In place of buzzer, here we are creating visual alarm, so we are using LED. Our whole project can be divided into three modules, which are password checking mechanism, which uses keypad and LCD screen, locking mechanism, which makes use of stepper motor, and motion detection system, which makes use of PIR sensor, LED and LED. This is the whole interfacing diagram. As you can see here, microcontroller 8051 acts as a centralized unit between all the other devices. LCD screen is an integral part of microcontroller 8051. And along with that, here buzzer is for creating audible alarms. We are using LED for our project, so we are creating visual alarm with LEDs. PIR sensor is used for detecting motion, and stepper motor is basically used in locking mechanism that I will elaborate in the incoming slides. And keypad is used for reading input for the password. Okay. So this is the first module, that is password checking mechanism, which makes use of keypad and LED interfacing with 8051 microcontroller. On the screen, you can see this is the code implementation of our project, where we have initialized P0 as an input code for reading the data from the keyboard. And K1 and K2, one more thing that we are here, instead of using 4x4 keyboard, we are using 2x2 keyboard. That is, we have interfaced that 4x4 keyboard in such a way that we will be able to use only 2x2 keypad. And moving ahead, this is the code implementation of LCD and keypad interfacing. And one more thing that we are using polling method. Polling method is basically like we are checking each and every key every time whether that key is pressed or not to read the input from the keyboard. This is the matching mechanism, like password verification, you can say. Here we are using 000, that is 4 times 0 as a password. And if user enters 4 times 0 continuously, then data is displayed on the screen that is password verification is successful. And if some other values are being given by the user, then password verification fails and error message is displayed to the user stating that some error is there. This code is for initializing the LCD, that is what all values that we are reading from the keyboard, that values should be printed by on the LCD. So we are using initialize the cursor on the LCD, and these LCD commands that we are using for the same task. This is the video demonstration. So I'll play the video so for the better understanding of yours. Okay, so this is the whole interfacing that we have created here. As I have already said, we are using 2x2 keypad. So the four keys that we are using is 4, 5, 1, and 0. Okay. For the correct password and incorrect password, we have different video demonstration, and I'll show you. Okay, see this video demonstration. So as you have seen here, user entered 4 zeros. That was our password. So success message is displayed on the screen, and the other modules of the system becomes active. One more video demonstration for wrong password. So as you have seen, instead of entering 4 times 0, here user enters 0 and 1, which is a wrong password. So an error message is displayed on the screen. This was all about password checking mechanism, which is the first module. And once the password verification is successful in this module, then only other coming modules of our project will become active. So the next module of our project is locking mechanism, which uses stepper motor. This is the code implementation, and what this code does actually is, here with this code we are trying to rotate the stepper motor by 90 degrees. Okay, and a latch type handle is attached to the stepper motor, and a hole is added at the right place to demonstrate the locking mechanism, that whether uh, the door has been locked or not. This code gets only executed when the given password by the user is correct. This is the video demonstration of the same. So till now you have seen the lock is going inside the hole. That is, we have that takes place when we successfully enter the password. Now what happens if we want to unlock? So if we want to unlock, then we have to again enter the password, and unlocking will take place. And for doing so, we have used interrupts. This particular line that moving the value of 81 in IE. So we are using interrupt for that. And here is the video demonstration. So I will start from 23 seconds, just a minute. Yes, yes, now lock. So this was all about door locking system that we developed. And moving to the other module, that is the detection system, and that is the main part of our project. This uses PIR sensor and LED in our case. Here 8051 acts as a central unit which takes input from the PIR sensor and gives that input to the LED. This is the code implementation, and going into the depth of code implementation, what we have done is we have utilized pin 1.0 of 8051 microcontroller to read the data from the PIR sensor, and here pin 0.0 is used to give the data to the LED. That is to switch on and switch off the LED once motion is detected. Okay, and this was the last module. With this, we come to the end of our presentation. Thank you and have a good day.